Yeah. This is joint work with Santiago, Balseiro at Columbia University, and Mohammad, Mahdian, and Vahab, Mirrokni at Google Research. Yeah. So budget constraints are common. There are many problems where there are agents with some kind of financial constraints. The motivating application for this talk is coming from online advertising. So in online advertising markets, we have many online ads that are being sold through repeated auctions. Advertisers are bidding in real time for opportunities to show their ads on certain websites. Often, these advertisers have daily budgets that limit their total expenditure over these auctions. In practice, online advertising platforms can help pace advertiser spending smoothly over the time horizon using what are known as budget measurement mechanisms. So by using a budget measurement mechanism, the advertiser's budget constraints will be satisfied over the time horizon. The question that we are interested in is the following. What are incentive properties of such budget measurement mechanisms that satisfy budget constraints in expectation? So in this work, we study incentive properties of mechanisms that satisfy budget constraints in expectation. So this is in the ex-ante sense. We introduced the notion of budget constraint incentive compatibility for this purpose. And we'll use this notion in two ways. We use the notion to characterize Bayesian optimal mechanisms with respect to the profit, utility, and welfare objectives in the independent setting, where advertisers' values are independently distributed. And also use a notion to determine incentive properties of several budget measurement mechanisms used in practice, and also study in the literature. And this will be in the correlated set. There are many related papers to our work. So there are many papers that study budget constraints. Most of them study budget constraints as a hard constraint, which has to be satisfied in every realization of random events. So they study optimal mechanism design, approximately optimal mechanism design. There are also papers that study return on investment constraints. There are some similarities there. There are also many papers that study budget measurement mechanisms in online advertising applications. So with that, let me give you our model. So in our model, we have a seller. He has T items to sell sequentially over time. So T is going from 1 through capital T. There is a fixed opportunity cost C per item sold, such that if an item is sold at price P, then the profit for the seller will be P minus C. If not, then the profit will be 0. And the seller implements a mechanism to determine the allocation and payment for each item over the time horizon. There are n buyers. Each buyer I has value xit and submits bid bit in each round T. Buyers' values can be arbitrarily correlated according to some continuous joint distribution F with density lowercase f over the support calligraphic X. So this support is rectangular such that each buyer's margin distribution is supported on the support calligraphic X subscript I. Each buyer I has budget BI, which is to be satisfied in expectation. You have two assumptions. We assume that values are drawn independently across rounds. We also assume that the joint value distribution and budgets are known publicly, so to the seller. In this model, we restrict our attention to stationary mechanisms and stationary equilibria. So that means the seller will repeatedly implement a single round direct mechanism QM with allocation rule Q and payment rule M. So it's a direct mechanism in the sense that the reporting space is a value space calligraphic X. And I'll be using QI, MI to denote the interim allocation and payment rules, which are parameterized in terms of the value ZI and report ZI prime. We restrict our attention to stationary equilibria, which arise when buyers implement stationary bidding strategies. So these buyers are repeating single round bidding strategies over the whole time horizon. So under a stationary mechanism and at a stationary equilibria, we'll have that the budgets will be depleted smoothly over the time horizon. So this restriction to stationary mechanisms and stationary equilibria is for analytical tractability, but this is also a reasonable assumption when we have when we have a large market, so which is the case in online advertising markets. So previous work have shown that this is a reasonable thing to do when we have the numbers of rounds and buyers are large and the values of the items are small relative to budget. So let me define budget constraint incentive compatibility. We say that a direct mechanism is budget constraint incentive compatible, or BCIC for short, if bidding truthfully is an optimal best response for each buyer among all budget feasible bidding strategies. So that means, mathematically speaking, it means that for each buyer I, sigma TR, which is the truthful bidding strategy, is a maximizer among all bidding strategies, such that that maximizes buyer I's expected utility subject to his budget constraints. So which says that buyer I's expected expenditure is at most his budget BI. I want to emphasize here that BCIC considers only those deviations that are budget feasible in expectation. So we can compare it to IC, which is the standard notion of incentive compatibility. So this is a notion without budget constraints. So under IC, we consider all possible deviations. But on contrary, in BCIC, we consider only a subset of those deviations. So in this sense, it's a weaker notion. And in fact, we can show that IC implies BCIC, but the converse does not hold. We also have a more tractable characterization of BCIC as follows. We can show that a direct mechanism is BCIC if and only if for each buyer I, there exists some scalar multiplier lambda I, such that the following two things hold. So the first thing says for all xi and xi prime, xi times qi xi minus 1 plus lambda I times mi xi is at least the same quantity, except we have the report xi prime in the intervals, so intervals qi and mi. And the second one says that t times expected value of mi xi is at most the budget bi, and lambda I is at least 0. And also the complementary condition between these inequalities hold, meaning one of these inequalities is tight. So we can compare to IC as follows. So when we substitute lambda I equals 0 into the first part, then we get exactly the IC constraint, which is shown at the bottom. So in some sense, BCIC is a relaxation of IC, but it also takes into account the budget constraints. Okay. So this proposition can be proved using standard convex duality theory. And this is the characterization of BCIC that we actually use in solving for Bayesian optimal mechanisms and also analyzing incentive properties of budget measurement mechanisms. So I'll give you more details on these two items. So let me begin with the Bayesian optimal mechanisms in the independent setting. So in the independent setting where the buyer's values are independently distributed, we can characterize an optimization mechanism. An optimization mechanism that yields a maximal objective value at a station equilibrium such that each buyer participates in each round. Each buyer realizes expected expenditure that satisfies his budget constraint, and each buyer has no incentive to unilaterally deviate to a different budget feasible strategy. And we can characterize optimal stationary mechanisms with respect to the following three objectives. So seller's profit, the buyer's total utility, and social welfare. Because of time constraint, I will only be talking about the seller's profit objective case. So by the revolution principle, we can, it suffices to solve for a direct mechanism that satisfies the BCIC constraint and the standard individual rationality constraint, IR, and assume that the buyers bid truthfully. So let's consider the profit objective. Assume the buyer's value distributions are strictly regular. Under this assumption, we want to solve the following optimization problem. So we want to solve for a single round direct mechanism QM that maximizes a profit subject to the BCIC constraint and IR constraint, where the profit is given by T times sum over I, expected value of mix minus c times qix. So we can solve this optimization problem and obtain the following result. A profit optimal mechanism qm is characterized by n parameters. So gamma i's that are in the range of 0, 1, such that each bar I wins if 1 minus gamma I times psi I xi is at c, and the quantity 1 minus gamma I times psi I xi is the maximum among the buyers. And buyer I pays the minimum bid to win if he actually wins. So here psi I is the virtual value function for the buyer I. So under this profit optimal mechanism, what's happening is that each item is assigned to the buyer with the maximum penalized virtual value, 1 minus gamma I times psi I xi, that is at least the opportunity cost C. So the penalization is through the multiplicative factor 1 minus gamma I. So if you're familiar with the Marston's classical result, this mechanism might look familiar to you. In fact, you can derive this result using the techniques that were used to prove the well-known Marston's lemma, and also using Lagrangian duality to handle budget constraints. The last thing that I want to point out here is that this optimal mechanism satisfies the BCIC constraint with lambda I equals 0 for every buyer I. So that means this profit optimal mechanism is not only BCIC, but also is incentive compatible. So yeah, so that's that. Now let me move to the last part on the incentive properties of budget measurement mechanisms. So I already gave you a bit of background in the very beginning. So in this setup, we have online ads that are being sold through repeated auctions, and advertisers have budgets. So for situations like this, we have budget management. It's a common feature that advertising platforms provide and advertisers use. The main idea is that advertisers, i.e. the buyers, will specify the maximum daily amount they are willing to spend. And the platform, the seller, will guarantee that the budget constraints are satisfied by implementing some budget management mechanism on behalf of the advertisers. So for example, when you go to the account setup page for the advertisers, for the Google's AdWords service, which is a search keyword service, under bidding and budget, under delivery method, there is a standard option of showing ads evenly over time. So this is budget management, and this is something that platform is doing on behalf of advertisers. For our purposes, a budget management mechanism is a stationary mechanism that depletes budgets at a constant rate over the time horizon. The budget management mechanisms that we consider are parameterized by n parameters. So there is one parameter per buyer, which is to be determined by the seller. So for example, they can be personalized user prices. So under a budget management mechanism, the allocation and payment for each item will be determined in terms of the buyer's bids and also these parameters. So we considered 6 different budget management mechanisms. So let me go through them quickly. So in reserve pricing, we impose personalized reserve prices for the buyers. The second one is bid shading. Here we shade each buyer's bid by some multiplicative factor. In thresholding, it's similar to reserve pricing in that we drop buyers with low bids with using some thresholds, but we do not use the thresholds in order to determine the payments. The fourth one is throttling. This is where we drop each buyer with some probability independently. And lastly, we considered 2 versions of multiplicative boosting, where we allocate an item only when the winning bid is at least some multiplicative factor greater than the competing bids. So these mechanisms control the buyer's expenditures through different means. To determine the incentive properties of these mechanisms, we had the following 2-stage setup. So first, recall that we have the buyer's joint value distribution, and budgets are publicly known to the seller. So here we're assuming that we're in the correlated setting where the buyer's values can be correlated. For each budget management mechanism, we go through the following thought process. So in the first stage, the seller chooses a system equilibrium, assuming system equilibrium given his prior information and assuming that the buyers will bid truthfully. So I'm not giving you the mathematical formation of this system equilibrium, but the main idea is that the seller chooses the best possible parameters for the buyers such that each buyer has no incentive to unilaterally change his parameter if he was given a chance to do that. And such that also budget constraints are satisfied in expectation. So this is the first stage. Then in the second stage, the buyers then will choose their budget feasible bidding strategies while conditioning on the parameters set by the seller in the first stage and anticipating the best responses of other buyers. So now in stage 2, we then consider whether we would then check whether the buyers have incentives to unilaterally deviate to a different budget feasible strategy other than truthfully bidding. So here's our results. So as you can see, different budget measurement mechanisms have different incentive properties. So we can show that visual pricing, throttling, and alternative multiplicative boosting satisfies the standard notion of incentive compatible. So this is assuming that the buyers can consider any possible deviations. On the other hand, we have bid shading, multiplicative boosting. For these mechanisms, they do not satisfy the notion of IC, but instead that satisfies the weaker notion of BCIC, which we define in this work. And lastly, we have thresholding. This mechanism satisfies the neither notions of IC and nor BCIC. Yeah, so these are the results. So lastly, let me quickly summarize. So in this work, we introduced the notion of BCIC. We use the notion to characterize Bayesian optimal mechanisms in an independent setting where the buyers' values are independently distributed. And we also use a notion to determine the incentive properties of budget measurement mechanisms in the correlated setting where the buyer's values can be correlated. So I left out some details, some technical details. For further details, you can check out our paper at this link. Yeah, so